Thank you all for joining today for the webinar on developer-friendly security rules to prevent vulnerabilities from ever making it into production. Right. The topic of the webinar kind of signifies what we're going to be talking about today. What we're going to focus on is some of the studies and research that we've been doing here at Shift Left. We've been speaking to a lot of developers, engineering managers across the world. I believe so far we've spoken to close to 200 people. And some of the insights that we've gotten from those conversations. And then that got us thinking as to how we could solve the problems that were pretty evident in today's development lifecycle when it comes to security. And I want to walk you through some of the work that we have done, and then some of the things that you should be looking at when looking for solutions in the market, right? So how can I have application security without affecting my developer productivity, without affecting the velocity of it at which I release features, the velocity of my software development in general. So the conversation that we were having with all these developers and developer community, one of the questions that we asked and the response that we got from developers is there is a significant disconnect between application security and engineering workflows. Right? Like the way that application security looks at the workflow, the way that developers have a workflow, there's a significant disconnect. And 96% of the developers that we spoke to said this clearly hurt their productivity. Right? And productivity in the sense focusing on what they're doing, which is feature development, and then also focusing on getting those features stable and strong in terms of removing bugs and ensuring that the feature works. At the same time, supporting the features that have been deployed in the market, so maybe like bug fixes and hot fixes. So all of these, the normal process that they follow, they said application security, whatever they're trying to do, comes in between. Right? It hurts their flow. It is making them less productive. It is slowing them down. It is taking them their focus away from what they like to do. So this got us thinking. Okay, so now there's a very clear majority here, like 96% is very statistically significant, especially given, as I said, the sample size of 200 people. So we were trying to then dig deeper, trying to see, okay, why is this disconnect? Like what is causing this disconnect? So then we started asking more questions, and then this diagram is familiar to any developer, right? Some of these iconography is from CI/CD systems out there like GitHub, and this is the day in, day out what developers do. So someone who's not familiar to this, let me quickly explain. So you've got this master branch. So that is where your source code, the life of the application is in a source code context. And then whenever a developer or a set of developers are tasked with developing a new feature, what they first do is branch off from that master branch. Right? And this is very true for distributed development environments like Git. Companies which are still in kind of a centralized environment, it's slightly different, but let's look at what most companies do, which is this kind of a model. So the developers would then branch off, wherein they can then go work in their sprints, in their cycles that they used to. They start modifying a set of files, they make commits, and then they do the process of, reviewing the code among themselves, peer reviews. Then they might run some unit tests. They would fix the bugs in it. And then once everything is set and done and they feel like this is ready to be merged back into the master branch, that is where this merge happens, right? So this is where that code would then go back. And the master branch is where it's the long living or like the stable branch, like anything that has to make into it has to go through some checks. And then on that branch is where the CI/CD systems would come in. They would, like build it. They would then deploy it. There might be QA. There will be testing, different kinds of testing, and then finally it would get released to the customer. And so this is how the source code lives and the development happens. Now then this is what developers use. Now we then try to figure out, okay, how does application security work on this? So they come later in the process, right? They take the code most often after it's been released, because due to various factors, like how long it takes to scan, the number of applications they have to scan, the ratio between applications and developers to application security team, right? That's often big. In most big companies we speak to, we see anywhere from 50 to 200 developers to one application security person, right? So it's just not possible for that person to keep scanning applications on a regular basis. So what they do is at some point in a released branch, they like take that point in time code, they run it by some static analysis tools, and then they triage it to the best of their knowledge. So their knowledge is more outside in perspective, wherein they say, okay, there's this application, it's external facing. They know this touches the database. They don't know what all it touches in the database. They don't know what tables it touches, but it is touching the production database. So, okay, this application shouldn't have any SQL injection vulnerabilities, right? So that's kind of a policy they would have. And then they triage the findings based on that, right? Wherein they're saying, okay, like, let me look at the vulnerabilities, let me see if it meets any of the conditions I have, and then they come out with a list. Now, why do they have to do this? Well, as all of you would know, the output of most static analysis tools is pretty long, right? Like for even small applications, it might give out like 200, 300, 400 findings. If I were to just throw it off the wall into developers, it's just going to sit there not getting acted on. So application security does that first level of triaging. Then they come out with that list of vulnerabilities, which they think is a good list. And then they send it off to the development team. Now, immediately one disconnect is obvious, right? A developer wrote the code, but the feedback is to the development team, because the security person obviously doesn't know which developer wrote what, right? And then if he or she has 20, 30 vulnerabilities, it is tough for them to then send it off to individual people. They send it off to, say, the manager of the team saying, hey, these are the vulnerabilities in the application, work with it. So now the development team at this point obviously would have multiple issues with this, right? So it's questions like these where, okay, the first obvious question or the first obvious reaction is, these are all false positives, right? You're giving me 100 off the bat. I can see this is a lot of them are false positives, and now I need to like take my team off or like myself off what I'm doing to trash this further. That's one. Second is, okay, this is a true positive. Now, which developer wrote this code? I need to go find that out. And as most of you are well aware from your experience, developers work in sprints. They work in projects. They are not doing the same thing. They're not working on that same file from once they're done with a feature. Right? Yeah, they could, but most often they're moving on to something else. So it is not like, okay, hey, it's this file, that means it's this person. Right? Multiple people touch the same file, same project, same library. And then even if I find out the developer who did it, it's like, okay, I wrote this code ages back, right? I wrote this 3 months ago. Now you come and tell me to go fix this vulnerability. I don't even remember what I wrote yesterday, right? Because I mean, in the moment when you're focused, you have full context of what you're doing, you understand the entire system. But then when you move on to the next project, next piece, it takes you time to get back into that context, right? It's not simple to just go in, change something, and then move on. Because I mean, if it's a bug, and it says that okay, hey, the requirement says it shouldn't take more than 12 characters. Okay, I forgot to put that check. Easy for me to do that. But if it says that, okay, hey, there is this SQL injection vulnerability, now go figure it out. So I need to figure out, okay, where is the input coming from? Okay, where is the SQL query happening? What is it doing? Is it important? Okay, have it been sanitized? Is it my code? There's a lot of questions that the developer has to understand and get into context. So it's not easy to fix. And even if it's easy to fix, then the question comes in saying, okay, I have to now rewrite a lot of code. And the most common thing that happens is when it's 3 months after the fact, you write something and then you have layered on additional features on top of it. When you change something, the impact is pretty deep, right? You touch a piece of code doesn't mean that everything is done, right? Now you need to think of the implications of what else could break. You need to then work through those flows. You need to, of course, test those. And even if the developer says he or she is done, it doesn't mean that the product can be just released, right? There's this QA and everything that needs to happen on top of it. And then it all goes back to the question of why fix something if it's not broken, really. Right? So there's a lot of issues with how AppSec works in this model. And that goes back to that initial metric or the stat saying almost all developers hate this process, right? They say this totally takes them off from what they like doing. It is affecting their productivity. And there are also things that have happened which increase these disconnects, right? Wherein if you look at, say, 10, 15 years back when application security and static analysis were invented or were common to what happens today, most companies we speak to are releasing more frequently. They're updating their code, they're updating their features on a much more regular basis. But when you looked at how often that code is being analyzed for vulnerabilities, it is very little or very infrequent. Right? So on the left-hand side, when you have organizations saying I'm 70% of companies that we speak to are releasing multiple times a month, 82% are scanning monthly. Right? So there's a huge disconnect there. When 18% are releasing daily, just 0.3% of them are scanning daily. Right? So this is increasing that disconnect. Like I'm pushing out features and then it'll be weeks or months after which I'll be getting feedback on them saying, hey, there is some vulnerability in what you wrote, fix it. So this is increasing that disconnect. And then we spoke to application security and they're like, yeah, we are aware of this disconnect. So we asked them, okay, what are you doing to make this better? So they said, okay, we are putting security into the IDE right where developers write the code. And then we asked developers, okay, does that work for you? They're like, no, that's exactly where it hurts us the most. And we were interested, saying, okay, hey, no, but if I give you immediate feedback when you write code, isn't that good? And then we saw what they are experiencing, and it was interesting. So they said, okay, you are putting something into the IDE, which gives me immediate feedback. And then what is the feedback that I get? So most of the tools that give you feedback in the IDE do what we call as linting. Linting is looking for patterns, right? Wherein it says, so it could be first common one could be coding style patterns, saying, okay, hey, you're putting a variable, it needs to be camel case, or it needs to be in a specific structure. Or if you're initializing or encoding pattern for some language, you say, okay, whenever you declare, you need to initialize. So things like those are the basic stuff, which is good. Over time, you might learn those, so you won't get that feedback. But then the second one is security feedback. And there is where the tool is focused on what you're typing at the moment, right? So one thing that the developer showed us is he or she they declared a variable, and then immediate feedback is this variable is not being used anywhere. I'm like, yeah, but I just declared it. I know I'm gonna use it. But then when you keep getting this feedback, so if you've used tools like Grammarly when you write documents, which gives you feedback on grammar and language usage, or comparing it to tools like if you've used Microsoft Office in the 90s and you're aware of Clippy, right? Like you start writing something and immediately Clippy pops up and says, hey, looks like you're writing a letter. Do you want me to help? And then it starts putting in subject lines and from and to. And I'm like, yeah, no, I'm writing a diary. You're like totally giving me wrong feedback and you're annoying. And if you're aware of how, or if you remember how Clippy worked, and even with the security tools in the IDE, they are running on the developer's laptop. They are consuming resources, right? Developer showed us how the system actually slows down when the IDE plugin from the security tool is giving them feedback, right? And then it's like they were typing something and there is a delay, right? And it is annoying. And then I totally agree with the feedback there. So we're like, okay, so whatever application security is trying to do as a solution to that app disconnect is actually making things worse. So that is also not working. So then we went to figure out, okay, what could possibly work then? Right? Like what is the approach that developers might like? So then we were looking at different workflows and in the application development workflow that already exists. You're trying to see what is a feedback mechanism that developers are used to. And one such is feature bug remediation, right? So wherein the same diagram, but I've added some more things here. The developers make a feature branch, they make a commit, they make a pull request, and then immediately in that CI pipeline, there is automation to execute unit tests. The unit tests give feedback saying something is wrong, something is broken. The developers immediately fix it, right? Because one, it is unit test, they know the feedback, and second, it is part of the process, right? So they get immediate feedback and they fix it, and then they move on to merge the code at the end of it. This workflow really works well for developers. Developers like it. Developers never leave their environment, right? Like as soon as they write the code, as soon as they're ready to like build it, they're getting feedback. And then the feedback being immediate, it is very relevant, right? The feedback is not saying, hey, 2 weeks back you wrote some code, there is a bug in that. No, this is for the code that you just committed. And it is trusted because unit test over time has been developed in-house. It takes care of the standards, it takes care of the checks that I mentioned. It takes care of things like, okay, the example I mentioned, a password needs to be of X length. That is in the unit test. And if the unit test says that is wrong, I'm like, yeah, I believe that. I can immediately put a check in place. So it is relevant and trusted. And over time, these standards get enforced in the sense the developers know, like if you get the same feedback 3 times, you learn. The next time it's automatic and you don't make that mistake. And there is individual accountability, right? Like when you make a pull request, in the pull request history, when the unit test fails, your reviewers can see it, your team members can see it. So there's that individual accountability to get it fixed. And of course, in most organizations, unless unit tests clear, you won't even be allowed to merge it, right? So there is that inherent urgency and need for unit tests to clear. So developers are very used to this. They do this day in, day out, and they like this flow. So then that got us thinking, saying, okay, can we do security like this? Wherein when you write code, like unit test, let's give you feedback. So then when we asked that to developers, they said, that sounds good. But when we've looked at existing security tools, static analysis tools, their security rules are not like unit test. Unit test is like code. It's for them, I mean, for developers, it is human readable. It is easy to modify. It's easy to update. Whenever new things are done, it's easy to add in those. But security rules don't work that way, right? One, most developers don't even have access to the rules. It is done by application security. And then you need to know the tool to make it work. So then one of the first findings that we said is, okay, security rules that doesn't require like a PhD to operate and manage, right? Like unit test, it should be very simple and straightforward. So an example like this, right, wherein you're saying it's a simple YAML file. You're saying, okay, compare my code against the master branch. Look for vulnerabilities that are critical of type SQL injection. Simple, right? So the example that I mentioned earlier, where when the application security runs the tool, static analysis, get a result, and there they are the ones who are triaging, saying, okay, this application shouldn't have SQL injection. Now this is part of the system. It's automatically defined once, and you then move on. And then imagine an application that never touched the database now starts touching the database. You can add this rule, right? So, or maybe it is giving like HTML responses, add in cross-site scripting. Or maybe this is an internal application, change critical to moderate or info. Or sorry, if it's an external facing application, change the severity. If it's an internal facing application, reduce the severity. If this application uses external services, wherein you're dealing with API keys and secrets, in the finding types, add in secrets on top of vulnerability. So this is very easy to use and manage. It's human readable, easy to define. And then you can have different rules for different applications, right? So you're not going by the same rule for all applications. You can even have different rules for different stages, right? Wherein when you have the master branch, and then when that application is being used for building, for staging, you could have a different, more lenient rule. When it's going to production, you make it more stringent, right? So wherein the developer then can work it on stages versus having to fix every vulnerability before they can even get it built and tested. And developers are like, yeah, this totally makes sense. This is the language we speak. They see this and they're immediately able to understand what it does. And they're like, yeah, we could manage this ourselves. Our security team works with us and helps define this. And then we know what to expect, right? They can open this up, they can read it, and they're like, oh yeah, so I need to be extra careful for this application. Any input that comes from external, I need to ensure that SQL injection vectors don't exist. Right? It's easy. So then that got us thinking. So we are like, okay, so starting from the beginning, we realize there's a disconnect, there's a hurt of productivity. What our application security is trying to do as inserting it into like the IDE doesn't work. Okay, what workflow works? The feature bug workflow works. Okay, can we do something like that for security? And that is the hypothesis that we then started doing the features in shift left, saying, okay, how can we use differently security rules in like a modern CI/CD environment? So let me do a quick demo. Sorry, let me share my desktop and do a quick demo. Okay. Okay, and then let me shrink this so it is more visible. Okay, that looks good. A bit smaller. Okay, that should be good. So, what I have open is my GitHub repository. Right? So I have my GitHub repository open here. It's a demo application that we built, and what I want to show you is how a developer would go about making a code change and how that workflow would work. So this application is a JavaScript application. And what I'm going to do here is open up one of my files. Let's do this one. Okay, this is purposefully vulnerable application. So please don't look at the quality of the code. It is purposefully written in a bad way. And what I'm going to do here is, so the workflow that we talked about, right? Wherein, okay, I'm a developer. I'm going to work on a feature. I'm going to edit some file. I'm going to create a pull request and then see how I take feedback immediately. So this file here, so I said it's JavaScript. And here there is an endpoint, right? So there's an endpoint saying /user input. So this is one of the things that you would, it's an endpoint on your application. And traditional JavaScript option. So there's a request that comes in from the end user, and there's a response to the user, right? And what does that happen? So this request, I'm not using. What I'm going to do is I'm going to start using that in this eval statement here, right? So wherein, let me uncomment this line, right? And then comment off this line. So what I've effectively done is I'm highlighted this line here. You can see. Let me maybe zoom in a bit more. Okay, that should be even more visible. So what I've done here is I've taken the request and I've directly used the user input in my eval statement. And then that is my result, and that I'm giving back as a result to the user. Now, you can imagine, and then it's clearly written here, it's a user input vulnerability, right? Wherein I'm taking an input, I'm not validating it, I am directly using it without any validation, sanitization, anything. And I'm using it in the response, right? So this could be remote code execution. User can inject some vulnerable JavaScript code, and it'll get executed in the browser. So now what I would do as a developer next is I'm admin on my branch. I have this commit directly. Normal developers would only have this option where it's creating a new branch. So I'm proposing this file change. And I'm not modifying any other file. So let me just create a pull request. Now, when I do this pull request, so a couple of things to note. I'm still in GitHub, right? So think of this as you're still in your repository. You're still working with code, right? You're maybe in your IDE where you've integrated it with Git. So it is doing the pull request and everything automatically. And in this, I'm updating this file, right? And I'm saying I want to commit this into master. Most organizations at this point would automatically assign reviewers based on the project, based on the file that you have touched. And the reviewers would be notified at this point saying, hey, somebody's created a pull request and is requesting a review. And here, the branch is protected, right? So wherein it'll say status must pass before it can be merged. And so there are some checks that are being executed. So here is where the unit tests would normally execute, right? Where your CI system would pull the latest code with the changes that you just made, and it would run the unit test against it and give you feedback. What we have done is we have integrated static analysis, shift left next gen static analysis right here. So now, while we were speaking, right, like in less than a minute, what it has done is it's pulled the code, it's built it, because CI would check if the code is syntactically correct. And then on top of that, shift left has also been invoked, and it's run static analysis. And it's failed, saying shift left static analysis findings. There's a new finding here saying remote code execution, command injection through the request variable. Immediate feedback, exactly like what we saw. And I didn't have to do anything to invoke this, right? I didn't click on a button. I didn't talk to my AppSec team. I didn't have to like log into a different console to submit a job, nothing. It just happened. And it is also happening in the flow that I'm already in, right? I created a pull request. I didn't open a new window. I am in the conversation of that same pull request where reviewers would come in. And in that flow, static analysis findings are put in. Now, when a reviewer comes in, he or she would now see this, right? So, and then since the check were not successful, the code also will not be allowed to merge. So even if the reviewer says from a code quality perspective, from a functionality perspective, this is good, this vulnerability exists and hence this code cannot be merged. The developer is expected to fix it. So that's one. Now, let's see what the developer would do. So, okay, there's a link here. I opened this. Login, single sign-on login, logged in. Okay, let me close this and we can just open it. Okay, so I click on the ID, a new tab, and it immediately takes me to the details, right? It takes me to the details saying, okay, it's a remote code execution, command injection through HTTP via request parameter. It says, okay, on line 11 on source, views.js. So I click on that, opens a new tab, and then shows me the code saying, okay, on line 11 in this source file, I'm like, oh yeah, I just edited this file. Okay, there is the request variable that is coming in from the user. Okay, I understand that. And then it flows and it says, okay, through the stack, it flows to line number 20. The user input is the route. Okay, line number 20. And then it is being used in the eval statement as parameter 1. Okay, let's see that. So I go in here, line number 20. Okay, I've linked it to the master branch. That's why I'm still seeing the commented one. But what will happen is you link it to the PR. Here it will say, okay, the result, eval statement. Okay, so it exactly showed me the flow, saying on line number 11 it starts and goes to line number 20, right? So line number 11 it started, flows all the way to line number 20 and uses it in eval statement. And as a parameter number 1. Perfect. Now as a developer, maybe I'm not familiar with what remote code execution is. So I go into description. It says, okay, HTTP data is used without undergoing escaping or validation. This could allow an attacker to execute code on the server, right? So if the user were to send in vulnerable code, it could get executed. So it's remote code execution. Now, what are the possibilities? What are the countermeasures? And then links to possible information where you can open up like CW77. It talks about, okay, it is in a command, there's no neutralization. So like all the description on like what you could do, consequences, depending on the programming language, if it's in C, if it's in Java, if it's in other languages. So, and then potential mitigation. So there's all this information the developer can learn on the fly as to what to do. Right? So immediate feedback. Now I can also collaborate here, right? Where if I am not the one, if the reviewer is the one who comes and sees this, I could say that, okay, hey, this is important, assign it to one of the users in the system, saying, hey, fix this. If they feel like, okay, no, there is somewhere else that we have put a check in place, you can override this so that the build can then go through. So all of those collaboration is also possible. Now, this is one quick example, but few things to note here is one, the whole developer workflow happened within GitHub, right? I never had to leave the environment. I got immediate feedback, and it is also trusted in the sense it is based on the policy that we have set. So if I were to go into the code repository and I go into my configuration, this is the security rule that has been put in, right? It is a pretty catch-all rule that I have put in. You can make it more fine-tuned. But here what I've said is stop if you see any vulnerability, right? Critical, moderate info, any level. So the developer is like, okay, this is why it got caught, and hence the feedback. So I need to work on fixing it. And then if I were to go into the pull request, this file that I edited, and then I modify it, I recommit, this vulnerability goes away, check will succeed, and then I can move on with my life and go to the next thing. And then the reviewer would also see it. They would come in, they will see, okay, there are some findings, developer made a fix, now the findings are gone. Okay, I don't need to think about security. Let me look at the quality of the code from a functionality perspective. Right? So this meets the requirements that we were discussing. So let me go back to the presentation, but at any point, there is a Q&A window that you have. You can send me questions there, and I will address them once I'm done with a few more slides I have. So let me share slide back. So we saw how a dev-friendly security rule would work. And this is not just a demo. I mean, this is being used in live production environments. So one of our customers, the Emirates Airlines, the Emirates Group, which also owns the airlines as a customer, and they are scanning every pull request that is being made, wherein they're able to fix vulnerabilities way more efficiently. They're seeing month-over-month decline in MTTR. MTTR is mean time to remediation, the time it takes to remediate a vulnerability. Vulnerabilities now even get fixed in the same sprint they are found in, right? So developer makes a change and it gets fixed in the same sprint. So it's never even making it into production. And then most importantly, the last 4 or 5 words is our engineers really like the process, right? That is a big statement when it comes to static analysis, right? And if an engineer really likes the process, as an engineer, when I used to write code, I learned to hate the static analysis tools that I used to use, because all the problems that we initially said, I would get these huge reports, go and fix these, all the productivity issues that I mentioned, but getting this feedback from a customer is it's truly remarkable. And from a benefit perspective, so not just that customer, but looking at across our customers, they're scanning more frequently, right? I mean, it makes it so easy to scan. And when you saw, I mean, yes, it is a small piece of code, but it was almost immediate feedback. Like our litmus test is, you make the change, you make a pull request, you go get a cup of coffee or tea or whatever you drink and come back to your desk, you should have that feedback ready. Right? That's how unit tests work, and that should be how static analysis also works. And if you can do that, then it will be used. And it is being used. We are seeing 110 times more scans happening. Mean time to remediation reducing 5x. 70% of vulnerabilities being fixed in the same sprint. 12% being fixed the same day. Right? Wherein the moment they get feedback, they are fixing it. So requirements for dev-centric, just to summarize what we've seen, when you're looking at solutions in the market, please keep these in mind. One, it needs to have developer as a first principle, right? Developers are the ones who write code. They're the ones who fix the vulnerabilities. And so they are the ones to keep in mind when the tool is being implemented. And developers need to be in a familiar environment, right? They shouldn't be expected to log into different systems, submit jobs, go find reports in different systems. It should be in the flow that they're used to, else it will not get used. And then it should be flexible, right? I mean, like the way I said, like we integrated it into GitHub in this example, but doesn't mean that I have to use GitHub, right? GitLab, Bitbucket, on-prem, cloud, Jenkins, CloudBees, Circle CI, like any environment, any system that you use, it should work. And it should be fast. As I said, get a cup of something to drink, you should get feedback. And concurrent scanning, right? You shouldn't have to wait for your application to be scanned, right? You shouldn't have things like, okay, hey, we've got this super fast CI/CD process, but then static analysis is this server sitting in a room somewhere. And so if somebody is scanning their code, you need to be in line. That shouldn't be the case. And it shouldn't be limited on hardware, right? Like what you saw right now, everything happened on the cloud. There was no limits. It's like it's scalable horizontally. So there's no limited by the hardware that the static analysis is running on. It should be accurate, right? So false positives is very common. In the example that I showed you, the reason I took that example is it was already an eval statement. I changed it to take user input. That's the only change I did. A lot of tools would have used that first code itself as vulnerable, right? Saying it's, okay, you're using an eval statement. You need to be validating that value that is being passed to eval, because they don't know where that value is coming from, right? But as you could see in our analysis, it was purely data flow driven. We can track the entire flow of data, and we only give you feedback when we saw that it is attacker controlled input. And you should enable the developers to teach the tool, right? So like the output that it gave, the policy that I showed you, you could tweak the policy and make the tool work in a different way. The policy is also now integrated into build rules, right? So you saw that the build was stopped, the CI/CD pipeline was broken, saying this vulnerability exists, and so you can't proceed. So you need that ability, and it needs to be comprehensive. Wherein what we did right now was a full scan of the application, right? It was not incremental, because if it's incremental, the line I changed is like, okay, you're already using an eval, you just change the input. That is all the tool might look at. But then when we did complete data flow analysis of where that input is coming in from, that enabled the vulnerability to surface. Now, in that example I showed you, it was only like 5 lines of code where that flow is. But imagine that flow is across methods, across files, across applications, and being able to track that, you need to be comprehensive and full scans, not just incremental line by line scanning. And it also needs to look for all kinds of issues, right? OWASP top 10, data leaks, business logic flaws, hard-coded secrets. It needs to be able to look for all of these in your code. I'll move on to the questions right now. But at this point, there is an option for you if you want to sign up for a free account. And I'm highlighted the word free. It's not a trial account, it is a free account. There is no time limit. Yes, of course, it has some usage limits on like the number of users you can invite and the number of scans that you can perform, but it's pretty liberal. You can do like 300 scans or so. So shiftlab.io/register, you can sign up for yourself and try it out. It's a self-serve model. You can, there are sample applications in there. You can go to the GitHub marketplace. That is very easy. If you have a GitHub account already, you don't even need to create a ShiftLeft account. You use GitHub to single sign on. You can tie your repository. You can do exact flow that I just did. The sample application I used is also there, the ShiftLeft.js demo application. You can also see the other programming languages that we support. You can see it there. So you can try it out for yourself. Okay, let me move on to the questions at this point. Okay, good. A lot of questions coming in. Okay, so one question is, can we build our own customized security rule set? Definitely, that is the key ability, wherein the example I showed you, it's just a YAML file, a text file that you can check into your repository. So think of it as like YAML files are used for infrastructure as a code. So this is like security as code. The policies are defined in human readable YAML configuration files, and you can tweak it. You can, as I said, make it specific to applications, make it specific to builds, make it specific to branches, make it specific to the life cycle. You can, the possibilities are limitless, because I mean, it is open and it is part of your repo and it is part of your CI/CD system. So yes, you can totally tweak it and make it work in the way you want it. Is there a way to create an issue with an issue trackers? Definitely yes. We integrate into things like Jira. So you can send it into Jira. What we see is when you get immediate feedback, you don't even need to go the Jira route, right? Like if a unit test fails, a developer normally doesn't say, put a ticket into Jira and then I will look at it. Normally the Jira route is when you're done with the project and then you're getting a bug report, right? So yes, that is also possible, right? So imagine if you were to find a vulnerability later on, Jira totally works. If the feedback is immediate, most developers might not even go to Jira. They will like work on it right away. But yeah, Jira works. All the data that is seen on the UI is available over API. So you can also integrate it into in-house systems if you want. And we have customers who pull data, integrate it into their own existing systems. There are tools like Zero North, etc., which give you like a centralized view across applications, across tools. We integrate into those, so you can pull the data there. Yeah, you can integrate it into pretty much anything. Does integration scan on our server or creates a copy and scans on your server? So yeah, the source code of your application never leaves your premises, right? So if you're running this on the cloud, it'll never leave your cloud. Wherever you're running the thing, the code would never leave that. What we do is we do the analysis, or what we call as a code property graph. We create a graph representation of your application. You can read more about that on our website, shiftleft.io. And that graph representation is for us to identify where the data flow is. The example that I often raise is for a sample project like WebGoat, in Java, the jar file is around 80, 90 megabytes in size. And our code property graph is around 6 or 7 megabytes in size. So it's like a 7-8% of the code. And that graph is what we take for further analysis, right? So we don't take your application, we don't take your source code. That never has to leave your premises. Okay, so there's a question about, again, an IDE plugin. I think I covered this in detail, but what I can say is the plugin that you have into the IDE, it doesn't do entire scanning, right? What it does is lower context. It is not completely scanning your application. So you can imagine, and you can try this out for yourself. You do IDE scanning, and then you can say, you can decide, or you can check, can you skip full scanning? Can you skip the other scanning? Can you depend only on IDE scanning? And no, that is not true. It needs both. And IDE scanning is done by other vendors because the full scans take forever, right? So if you were to compare speed, we can do around 1 million lines of code in less than 15 minutes. We can do 250,000 lines of code in like less than 30 seconds. Compare that to competition, we are like 40 times faster. 1 million lines of code would take 10 hours or more. Like yesterday, I was speaking to a customer who said his application takes 19 hours to scan with a competitor. 19 hours. Now, that doesn't even happen overnight, right? Like if I scan now, I'll get it back tomorrow the same time. That's pretty much how it works. So that is the reason why shortcuts like IDE scanning is implemented, but those are not complete. And the example that I showed you was a complete scan of the application within the pull request, so that it gives you feedback like how you do unit test. Right? Because for unit test to run also, you complete the code, right? It has to be buildable, and that's exactly how we are targeting the issue here. The languages it supports, please do check out the sign up for the free account, or you can check out the website. We support most major languages like Java, JavaScript, C#, Python, Golang. We even support infrastructure code languages like Terraform. So yeah, we support a lot of these. And then from our experience with most enterprise customers, these are the languages that they develop applications in. So yeah, so we do that. The shift left scans code once PR is raised. So what if you want to scan our whole code base? So yeah, so when you do the pull request, we are scanning the whole code base, right? We are so fast that it happens within the pull request itself. But you can also initiate other jobs. Yes, you can totally do that. We have customers who keep scanning the master branch. So whenever something is merged, they scan the master branch. Whenever a PR is created, they scan the feature branch. They might have, from the master branch, there might be a branch for like hot fixes. They scan those. It can be integrated into anywhere, right? Like as long as you have access to those branches, the CI system is integrated into those, you can integrate into those. You can even run it off your developer machines, right? If you want to, the graph creation can be done on a developer machine, and the graph then gets uploaded to our premises, our cloud. You could do that too. If you have regulatory requirements and you say that, okay, I want to scan once in a quarter for a specific application separately, yeah, you can put that as a job. That also would get done. So you can scan it anywhere for any branch, for any part of the code that you want to. Totally possible. Okay, a quick time check, 10:55. Okay, supports incremental scan. So no, we don't require to do incremental scan. We don't need to do incremental scan. So quick note on incremental scan. So incremental scan is like IDE scans. Our competitors included that because full scans take forever. Incremental scans, from your experience, you can judge for yourself. Most tools, when you do a code change, and if they allow incremental scans, every few incremental scans, they require you to do a full scan. So imagine this use case of, okay, an application takes 20 hours or more to scan. An incremental scan takes minutes. If I have to do a full scan every 3 or 4 scans, on average, so for 4 scans, it takes 20 hours. You're still taking 5-6 hours per scan, right? If you average it out. And what we are saying is our full scan can be done in minutes most often, most cases. Right? And especially when it comes to like microservices and stuff, it happens in seconds. So yeah, we don't do incremental scans, we do full scans. And that way you're always getting the full set of results. The scan results are not changing after each scan, right? Where if you're doing incremental scan, you might catch something. When you do full scan, you might catch more. In our case, all scans are equal. Let me look at the other set of questions. Okay, what is the code property graph? Okay, so we've got a white paper on our website, which you can look up. What code property graph essentially is, as I said, a graph representation of your application. Let me switch on the exit poll while I'm at it, so you also get an opportunity to do that. Okay. So please take a few moments to answer to that poll while I explain what the code property graph is. So what a graph representation means is take the application source code and look at where the data is flowing, right? So there are multiple graph representations that can be created. There's something called as control flow graph, wherein it shows how control is flowing within your code, like what method invokes what method, where is the data, where is the control flowing. And then once you get into a method, you can see into like how the what we call as an abstract syntax tree is, right? So like the syntax of that part of the code, saying, okay, hey, what variable is being declared? How does that variable get the value? So what is being assigned to what? And then where does that variable go to? So that is like the syntax tree. Then there is things like program dependency graph. Then there is layers on top of it where you have external inputs coming in. You have like data flowing into like the database or file system, invoking other applications. So all of this information gives like a blueprint of what that application is doing. Where is the data flowing in the application, right? So that is what the code property graph does. Now, why can we do what we do? The code property graph is unique in the sense all of these are in a single graph representation. If you look at other tools in the market, some of them don't do all these graphs. Some of them might just do abstract syntax tree. So that is where a lot of false positives happen. They don't do like control flow. So you don't know like where the thing is flowing. You might be looking at a smaller context. That is one. And then even if they were to do it, they might be doing it as disparate graphs, discrete graphs, in the sense you then have to correlate between these graphs to understand what is happening. So what we do is we do unique in the sense everything is one representation. Now, when it's one representation, there is no correlation. It is all contained. Let me give an analogy that we do with customers. So what I mean by correlation is, imagine if you were using Google Maps. And compare that to how you used to use maps on, say, in a book or on paper. If I have to find a route from point A to point B, I look at one map. And then once I've identified that route, then if I want to find restaurants on the way, it's a different map. Oh, by the way, if I want to find a fuel station, that's another map. Oh, and then I just realized, okay, maybe that road has tolls and I want to avoid that. I need to maybe look at another map. And then I need to now look at 5 different pages and figure out what's the best route to take. And then figure out where to eat, where to put fuel, and how to avoid tolls. Now, Google Map doesn't require it to do that. All of these are options on a single view, right? I could do these, then I could search for nearby, I could search for fuel stations on the way, I could avoid freeways, ferries, highways, whatever you want to avoid. All of that in a single route, in a single view. And that is exactly how code property graph works. Now, when that happens, as you can imagine, it is way more efficient. In our scanning, it takes way less compute and way less storage, and hence it's way more efficient. And that's why we are faster and more reliable. That's the top of the hour. Thank you so much for attending the webinar today. Hope it was useful. A little over half of you have responded to the poll. While you are leaving the webinar, if you could just take a few seconds to click that button before you leave, I would highly appreciate it. Thank you again for taking time. And final reminder, shiftleft.io /register if you want to sign up for the free account. Thanks again.